All right, folks, we're going to wrap it up with absolute value inequalities today. So we're going to just look at a few more, slightly more complicated questions, just in that there are more steps to them. And then we'll look at some special cases. And then we're about done. So just to recall from yesterday, we talked about our steps here. First thing we need to do is isolate the absolute value. Second step is to decide if it's an and or an or. And we remember if it's a less than, it's an and. Greater than or more than, it's an or. We set up our two cases. One case kind of as is, as written. The second case is that sort of copy, switch, flip. We write it, we reverse the direction of the inequality, and we take the opposite of whatever is to the right of that inequality sign. Then we solve and we graph. So ands and ors, these compound inequalities, end up being ands and ors. So here's an example of kind of a longer one, right? There's a lot of stuff going on outside that absolute value. And what we need to do is, before we decide if this is an and or an or, we're going to isolate the absolute value. So right now, we have a less than or equal to, right? But I don't know that that's going to be a less than or equal to when I'm all done with isolating. So I'm not going to make that call on and or until I have isolated. So again, I'm never going to distribute into an absolute value sign. Bad things happen. I would start here by subtracting 4 from both sides. That gives me negative 2 times the absolute value of x plus 3 is less than or equal to, that's negative 12. And now I'm going to divide by that negative 2. And when I do that, because I've divided by a negative, I have to keep this in mind. I'm reversing the direction of the inequality sign. So that went from a less than or equal to now a greater than or equal to, right? Because I reversed the direction. So keep that in mind. We don't make the call on and or until we have isolated that absolute value, because sometimes it flips. All right, so now this is a more than. This is going to be an or statement. And at this point, I'm going to set up my two cases to find those boundary values. X plus 3 equals 6. X plus 3 equals negative 6. And I'll find those two values, those two boundary values. X equals 3. X equals negative 9. And again, we're keeping it simple here. This is an or statement. There's my negative 9, and there's my 3. Both closed circles. Or statement goes that way. Okay, another problem here. Let's see. So again, don't distribute into the absolute value. Let's start by subtracting 9 from both sides. And our idea is isolating that absolute value. Is less than 19 minus 9 is 10. And then we would divide by 2. And we get the absolute value of x minus 1 is less than 5. And now that I've isolated, I can set up my two cases, keeping in mind this is an and. X minus 1 equals 5. X minus 1 equals negative 5. These are very procedural. Add 1 to both sides, add 1 to both sides. I get x equals 6. X equals negative 4. And again, keeping in mind it's an and. We're not looking at anything crazy. This year, 2020 has been crazy enough, and this is an and statement. I'll have open circle to open circle. I do want to just touch on special cases, so this is just a little sneak peek. I don't want you to worry about them. I'm not going to test you on them. I just want you to be aware that they do exist. We don't have time this year to dive deeply into them. So here's two examples of special cases, and notice what they both are. They're both absolute values that are related to a negative number. Just like we had those special cases or where we had no solutions with the equations, when that isolated absolute value was equal to a negative. Now we've got one that's less than a negative and one that's greater than a negative. So let's think this through. If I asked you to find all of the numbers whose absolute values are less than or equal to negative 9, well, that's never going to happen, right? There is no solution if that isolated absolute value is less than a negative. That can't happen. Less than negative 9 would be any other number that's even more negative than negative 9. I can't take an absolute value and get a number less than negative 9. Never going to happen. The other case here on the other side is the absolute value of x minus 5 is greater than or equal to negative 9. Well, any number I substitute in here is going to be greater than a negative number, right? Those absolute values will end up being positive. So the answer for this one would be all real numbers. Anything I substitute in for x, when I subtract 5 and then take its absolute value, that would be bigger than negative 9 because it would have to be positive. So again, just be aware we do have those special cases. I won't test you on them. They are out there. I want you to have seen them. Not a huge deal to us. Okay, we can recognize them and we can kind of reason them out. That's the most important part here. Okay, that is it. We have come to Friday. We're just going to practice these, and that's it. Test probably Tuesday or Wednesday. I haven't decided yet. This is Monday night when I'm making this video. I'll let you know. Okay, bye-bye.